let's grab this one right here. I'm looking at a circuit. This is homework right out of your book, okay? Unit 3, I should say, handout 2. I've got an RL series circuit here, looks like. And it's got a whole bunch of stuff here, okay, that it asks us to calculate. Now, I always try to approach these questions the same way. It doesn't matter if it's a series circuit or a parallel circuit or some other kind of circuit, okay? I always kind of try to tackle it the same way. And this is what I call the Van Andel way, okay? And I don't know how you learned it last year. And, you know, if you've got a better way, I don't care. You know, figure it out however you like. But what I try to do in every circuit that I am approaching is do two things. First of all, the first thing I go after in general, forget about what's on here, all right, guys? Because there's a lot of stuff up on here, and I'm going to worry about it later, okay? The first thing is calculate the current, okay? And I don't care what the circuit looks like, okay? Whenever I'm approaching a power kind of a question, I try to figure out the current in the circuit. And the second thing I do is I calculate the power factor. And you're going to see why I do it that way in a second. So how am I going to calculate the current in the circuit? Well, in order to calculate the current in the circuit, I'm going to have to calculate the impedance because I have the voltage, and if I have the impedance, I can easily calculate the current. Now, the first thing we're going to have to do, guys, because this annoyingly is in microfarads and Henrys, I'm going to have to figure out XC and XL. Okay, so I'm going to do that real quick here, and you can do it too if you want to. I'll just calculate it right here, okay? And I'm not going to, spend too much time on this. I'm going to calculate it real quick. Okay, guys, so I've calculated those with the formulas, and what that's going to do is allow me to, figure out Z, all right, guys? So, calculate. This is series, right? So I can compare them to the current. Okay, guys, it happens to be the first thing that it asks for here, guys. But even if I didn't ask for Z in this question, you would have to calculate it. Why? Because that's the only way to calculate the current in the circuit. And I'm going to, it happens to be F, okay? But I'm going to calculate the current next. It's the last thing it asks for. It's the first thing I'm going to calculate, or almost the first thing, okay? And I is going to be E over Z, right? Voltage divided by the impedance. oops. Okay, 4.626 amps. So again, we'll put it in here, 4.626 amps. Okay, so that's my always going to be, or it's 99% of the time, okay? I'm going to try to calculate the current in the circuit. I don't care what the circuit looks like. Just figure out the current. And you know how to calculate the current for every kind of circuit, right? You know how to calculate the current in a parallel circuit, in a series circuit, in every circuit. So I'm just going to calculate it, and I did it right there. All right, guys? Now, second thing I'm going to calculate is the power factor. Now, the power factor, there's a lot of ways to calculate that, okay, guys? But we know that the power factor, guys, let's see if I can find my sheet here. What did I do with it? I get rid of it right here. Okay, guys. We know that the power factor is P over VA. All right. We also know that, you know, P is always the adjacent, VA is always the hypotenuse. Okay. So there's a couple of ways I could calculate the power factor in this circuit. I could calculate this angle and hit cos, right? And I know how to calculate this angle. It's going to be this over this inverse tan, right? Opposite over adjacent inverse tan. But the power factor, and maybe I'm going to write it here, okay? Because the power factor for any legitimate phasor diagram that belongs to a circuit, guys, is going to be, the power factor is going to be the adjacent over the hypotenuse, okay? So it's going to be P over VA, it's going to be R over Z, it's going to be IR over I total, ER over E total. Whatever phasor diagram you have, you can always calculate the power factor. It's the adjacent over the hypotenuse. Now, if I didn't want to do it that way, I could do it by calculating the angle and hitting cos. And that would be fine too, okay? So there's a lot of different ways to do it. I'm going to calculate the power factor right now. I'm going to use the adjacent over the hypotenuse for this particular circuit, okay? And the adjacent is 20, and the hypotenuse is 25.94. So let's do that for a second. 20, and I apologize that this getting a little long, right? No, it doesn't matter. You guys got time. You got all day, right? 20 divided by 25.94, and according to this, it's 0.771, okay? So there's my number between 0 and 1, 77.1%. All right, guys? Now, I always calculate those two things first, because the third thing I try to do in any circuit, and I'm going to put it right here, is draw power phasors. Okay, so I try to calculate the current, I figure out the power factor of the circuit, and it's right there. Any triangle that I have for the circuit will allow me to calculate the power factor, and then I'm going to draw power phasors, and what that means is I'm going to, draw my power triangle, okay? And I don't know what these values are yet, but I do know it's going to look like this, right? True power, apparent power, reactive power. Now, I can't calculate the true power. Well, I could, it's ER times IR. I'd have to figure out ER and do all the math. I don't like using those formulas. I rather use some trig to calculate this out. It's pretty easy. What can I solve right now? Well, I know the voltage, the VA in the circuit is always E total times I total. And look, I've got E total and I have I total. So if I multiply these together, guys, I can always calculate VA. And don't be thinking that you can calculate their power using those two values, okay? That was level 1, this was level 3, okay? The only thing you can calculate with the total voltage and the total current is the VA. And that is sort of the fourth thing I do, okay, is I calculate the VA now that I know the current and the voltage was given. So it's 120 times, 4.626. Let's do that. 120 times 4.626 equals, looks like our VA is 555.1 volt amps, all right? And so I've solved one of my two sides here, and the answer is right there, 555.1 volt amps. Okay, now what can I calculate next? Well, look, I calculated the power factor. Where is it? 0.771. That sits right here. That represents this triangle right here. Now, since the power factor is equal to P over VA, it is fair to say that the power, if I transpose that, is VA times the power factor. All right, guys? And we just calculated the VA. It's 555.1. Power factor is 0.771. And I'm going to calculate that right now. Look, it's already in my calculator. Times 0.771 equals, looks like my true power for this circuit is 428 watts. All right, guys, so 428 watts. All right, guys. Last thing I'm going to calculate is the VARs. Now, I could go EX times IX. I'd have to, I got X. I'd have to figure out EX and I don't know what, okay? You could do it with that formula, but I don't like to. I rather use trig. This VARs here, guys, is going to be equal to 555.1 squared minus, because this is a short side, 428 squared. And I'm going to calculate this, and then we're going to quit this video, okay? 555.1 squared minus 428 squared equals root equals 353.5 VARs, okay? 353.5 VARs. Okay, guys, so now we've solved all this. So stick with me for one more minute. What am I going to do to solve a power circuit? Okay, as soon as I notice that it's asking about a bunch of power, step one, calculate the current in the circuit. Do whatever it takes to calculate the current in the circuit, okay? I don't care what the circuit looks like, calculate the current. If it's series, calculate Z and then use Ohm's law. If it's parallel, you're going to have to calculate the three currents and add them up as phasors, right? And then you'll have the total circuit current. Calculate the power factor for that circuit. Now, if you've already drawn a phasor diagram, any phasor diagram for the circuit, you can use that to calculate the power factor by calculating the angle and hitting cos, or just taking the adjacent and going over the hypotenuse like I did, okay? Step 3, draw a power phasor diagram, okay? And step 4, calculate the VA. And step 5, I guess you could say, is calculate the other two sides. Okay, and this works for every kind of circuit. Okay, as long as you do step 1 and 2 right, you'll get the VA, you have the power factor, you can calculate the power and the VARs using, some trig and formulas. All right, guys? Now, long video, sorry about that. And come back, because we're going to do another question. All right?